everybody. Good morning. So today is December 4th. We will continue with session 7.2. And then this Wednesday, we will have the last homework set, homework 12 and quiz 7. And so try to finish your submit your practice exam correction and wrapper, like all the missing work as soon as possible. So quiz 7 is on Wednesday, and then I will grade your quiz on Thursday. Then we can go over the quiz 6 and quiz solutions on Friday. Our exam is on Monday, next Monday, 10 to 12 p.m. It's going to be everything. The practice final exam is already posted on the course website. So I would say don't wait until the weekend to start doing your practice exams. Do it now. Okay? Yeah, because you have 3 finals, 2 finals on Monday. 1 weekend is not enough to study everything. Okay? So do the practice final exam tonight, and if you have questions, ask me. Okay? So today I have office hours from 1 to 1:50, and then from 3:15 to maybe 3:50, then I will go to the Andover Commons room 242, and there will be a study session there. So I will help over there from 4 to 5. So yeah, if you have more questions, come to the study session. Okay? So I will be there from 4 to 5. And then before like 3:50, I will still be in my office. Okay? And have you helped me to fill out the course evaluation? Let's see. So Blackboard and course evaluation. And let's see our response rate. So response rate right here, and then our class. Let's see. Okay, so right now we have 5 students already fill out the survey. So the response rate is 55.6%. So that means everybody will get at least 0.1 extra credits. Okay, so if I need 4 of you to help me to fill out the survey, then everybody will get 0.5 extra credits. Okay, everybody? So, yes, your comments are so important to me. Thank you so much. All right, so let's continue. So today we talk about the substitution rule, and last time, we talked about the antiderivative formula. We only know these 3 types of functions. The power law, right? If you have x to the some power p, then the integral is, remember when we take the derivative, the power dropped down by 1. So when we integrate, the power increased by 1. So the integral of x to the p is x to the p plus 1 over the new exponent p plus 1. And then plus c. And then integral of e to the ax is e to the ax over a. Because when you differentiate, you multiply by a. So when you integrate, you divide by a. You have to differentiating and integrating their inverse process. And this power law only works when p is not equal to minus 1. Because when p equals to minus 1, we use the log rule. Okay? Integral of 1 over x is natural log of x to the value of x. Yeah, everybody? How about the integral of 1 over x squared? Okay, so how about the integral of 1 over x squared? Is it equal to ln of x squared? Is it equal to ln of x squared? No! So this formula only works for 1 over x. It is something else, then you should not use this formula. Okay? If it's 1 over x squared, this is x to the negative 2, right? and we use the first formula. And when p is -2, what do you do? -2 plus 1 is -1. And then we divide it by the new exponent, which is -1. Yes, everybody? So the natural log formula works only if it's exactly 1 over x. If it's something else in the denominator, we don't use this formula. Is that clear, everybody? This is really a common mistake. Yeah, don't see something in the denominator and put that ln. No, that's not true. Okay, everybody? And last time we did this example, right? That one with the square, we are able to expand it and use the power rule. What if the power is 50? Do you want to extend it? No, right? Nobody will do that, right? So that's why we recognize this is a composite function. We use the U substitution. And how does that work? Well, first recognize there is a composite function inside the integral. And then we let U be the inner function. Okay? After we find the U, the second step is to find the differential. And we know du dx is g prime of x. And we want to use the differential form. So both sides multiply by dx. This is the differential form. Like this example, du is the derivative of 1 is 0. The derivative of x squared is 2x. dx. Okay, when you finish, put the dx. Remember I said 2 kids play on the seesaw? You need to have 2 kids. So you need to have du on one side and dx on the other side. You can play seesaw. Right? So don't forget to write down the dx. And then you realize, okay, our goal is to change everything in terms of u. Okay? So 1 plus x squared is u. This is u to the 50. And what's left? X dx. What is x dx? I want to solve for x dx. So both sides divided by 2. We get x dx is 1/2 du. Okay? And du, remember to put the du at the end. Right? The integral has 3 parts: the sum, the s, and then the function, and then the du at the end. Right? So don't forget that. Okay, right. Yes, dependence. And so we will get a simpler integral. So this simpler integral, you can use one of the 3 formulas to solve. In this case, this is the power rule. So we add 1 to the exponent and then divide it by the new exponent, 51. And then finally, so yeah, step 3 is you plug everything inside. You get an integral about u, and you integrate the u. And then the 4th step, you plug the x. So 4-step process. Okay, so common mistake is sometimes here, because when we find the u, we are taking the derivative. Okay, so even though we're looking for the integral of this function, but in the process of the u substitution, we need to differentiate. So sometimes students get confused about integration and differentiation. Do you still have that paper where one side is the derivative, the other side is the antiderivative? Yeah, because in this process it involves both. It involves differentiation and integration. So make sure you slow down and check your work. Are you differentiating or are you integrating? Okay, everybody? A second mistake is we need to get an integral about u. So sometimes students will substitute some of the term but not the other. So the student get a mixture of u and x. Well, where in calculus 1. This is one variable calculus. This integral is a single variable integral. Okay, everybody? So you should only see one variable, not 2. Okay? So you don't want to see a mixture of u and x. It's like Do you drink a mixture of milk and orange juice? Do you do that? You will do that? Mix the orange juice and milk together and drink it?
Yes.
Yeah. Okay. So here, right? Just get an integral about you. Okay? You don't want to get a mixture. Mm-hmm. Do you go to the restroom after you drink it? Yes. Okay. So this is the four-step U substitution. And I already put down the steps here. So let U be the inner function, and then find the du, and then plug in everything, get an integral with respect to U, and then integrate a simple integral, and then plug the x back in. Okay, so four steps U substitution. Okay, let's do a lot of exercise. By the way, sometimes if you get lost, like which one should I set you to be? Well, it's okay to try a lot of different options and see which one works. Sometimes there could be more than one way to solve a problem. Like this problem. So we let U be the inner function. Do you see an inner function? Yes, what is that?
Square root of square plus with 1 square.
Okay, so this problem, actually there are two ways to solve it. One way is to let U be the square root of x squared plus 3x minus 1. The other way is let U be inside the square root, which is x squared plus 3x minus 1. So you have two methods. Both of them work. Okay, everybody? But which one do you think is easier? The second one, right? With the square root, the square means the derivative of the square root, we use change, right? So yes, the second method is easier. So let U be the inner function inside, yeah, in the denominator and inside the square root. So this is easier. Let's do that. If U is x squared plus 3x minus 1, that's the first step. Second step, what is du? Plain. What's the derivative of x squared?
Du would be 2x or 2x plus 3.
Yes. It's 2x plus 3 and don't forget the dx. Remember, two kids play on the seesaw. We need both of them. So dx is like your baby. Don't forget your baby in the mall. Okay? And next, step 3. We want to plug in. Okay, do you see the numerator? We have 2x plus 3 times dx. Yeah, 2x plus 3 times dx. This is exactly du. Yeah? And then the denominator, what do we have? Square root of u. Yes. Check. Do we express everything in terms of u? Yes. Do we have a mixture of u and x? No. Okay. Yeah, actually, in Applied Calculus II, you will learn double integral. So mixture of u and x, something like this, we can have dx and du. And Cal 1, we only talk about one function, dx. What does this represent? Remember, if we have like bounds a to b, and then a function f, this represents an area under the curve. Okay, everybody? So this means area. The double integral will means, so you have function f is a function of two variables, x and u. What this means, you have x-axis here, axis here, and then you also have another axis. Your function is now like a surface on some area of the xy plane. Okay? So then this represents the volume under the surface. Okay, can you imagine you f of x and u is a surface in the space. And then your double integral represents the volume of it. So that's why here, this is a single integral. So you should only have one variable, not two. Okay? Two variables, it really means different things. Double integral is a volume under a surface in the space. And we also have triple integral. Okay? So think about it. Single integral is area, double integral is volume. How about triple integral? Okay? The triple integral, you have three of them, and then you have a function, let's say x, y, and z. dx, dy, dz. Well, x, y, and z is already in the space, right? The region, or you can say the domain, is in the space. The function f is like a density function in the space. Okay, like you have a ball, right? And then in the ball, different points you have different density. Okay, and when you sum them up, you actually get the mass of the subject. Okay, so area, volume, mass. So this is the. We will talk about those in applied calc too. Okay. So let's continue. Okay, we have 1 over square root of u. Okay, so this is the power law, right, everybody? What is the power of u? Dylan. Yeah, u to the negative 1/2. What is the integral of u to the negative 1/2? H? U to the, oh sorry, after we integrate, don't put the integral sign. So u to the 1/2, and we divide it by 1/2, right, everybody? And now, when we divide it by 1/2, it's the same as multiply by the reciprocal, okay? So we multiply by the reciprocal. We got 2 times u to the 1/2 plus c. And then finally, put the x back. U is x squared plus 3x minus 1. What? The du? Yeah, after we integrate, so don't put the sign. So the sum and the du is just a notation of the integral. After you integrate it, you don't put it again. So it's like when you take the derivative, right? So when you take the derivative of x squared, you get 2x. Do you put the dx of 2x? Do you put the derivative side again? No, because if you put the derivative side again, you get 2. You're actually taking the second derivative instead of just a single derivative, right? So after you integrate it, don't put the integral sign. The integral sign, it involves the sum and the du. Okay, both of them represent the integral. So both of them together represent the integral. After we integrate it, don't put them anymore. And this, yeah, we're finished. This is the solution. So 4 steps. Let u be the inner function, and then du is the derivative of that, and then change the integrals in terms of u, and integrate. So when we integrate, use one of the 3 formulas. Okay, the integral of xt, or the integral of e to the ax, or the integral of 1 over x. Okay, and then plot the x back. Okay, so this is the u substitution. Let's see. Part B. What do you want to let u to be? Any guess? 1 over x? Let u be 1 over x? Okay. Sometimes it doesn't hurt to try. Okay? So let's try. If we let u be 1 over x, then what is du? The derivative of x to the minus 1 is minus 1 x squared dx, right? Which is negative 1 over x squared dx. But do you see this thing in the integral? No. Right, everybody? We don't see this thing in the integral. And we don't know how to deal with the ln of x. Therefore, we shouldn't let u be 1 over x. Okay, so not that. Any other guess? ln x. Very good. By the way, never let u be x. Why? If you let u be x, du is just dx, and then you plug it in, you get ln u over u du. So you see this integral and this integral are the same. You just call the variable a different name. You get the same thing. So it does not help. Okay? This is, yes, some of the mistakes. Didn't let u equals x. Will this help? No. You just get the same integral. So you just call the variable different name. It does not help. So never let u be x. Okay. So we should let u be ln x. What's du? 1 over x dx. How nice! Because I have 1 over x dx. Yes, you see that? Okay. So the integral, you can rewrite this as ln x times 1 over x dx. Yeah, ln x over x is the same as ln x times 1 over x dx. Right, everybody? Ln x is what? Down J. Ln x is u. How about 1 over x dx? 1 over x dx is du. Yeah. Joseph, how do you integrate u? The integral is yes. And what is u? Look at the beginning. What is u? Yes. That's ln x squared over 2 plus c. Okay, yes, very good. Any questions? Also, I also want to write down some common mistakes. So, if sometimes students get something like this, no, du is never in the denominator. Okay, the du is always on top. It's never in the denominator. Okay, so be careful. Okay, and do not write something like du and then times u. No, the du is always at the end. Okay, everybody? Yes, those are some common mistakes. Du is at the end. Be careful. All right. So everybody, please try to do part C. Okay. What is the inner version? Oh, my answer is not here. How about let's take pictures on Wednesday? And everybody. So you have x here. That's how many do? Yeah, 6 and x here. So x here. Get rid of the 2. How do you get rid of the 2? Both sides divided by 2. Baby, yes. And you look at that. See, e to the x squared plus 1.
That would be one column so this one.
Yeah, that one.
Not with just the other x. So you would just do full e to the.
Yeah, full e to the u. If whenever you see that expression, you put it in the u. Yeah, everything else should remain the format. Okay, let's check our answers together. So all of you got u is x squared plus 1. And du is 2x. But some of you forget the dx, okay? Our baby dx. When you try to plug in, okay, so do you see the integral? You have x squared plus 1. This is u. Yes, everybody? And what's left? Do you see we have x dx left? And what is x dx? X dx is 1/2 du. Okay? Now you replace. You have e to the u. Yes? So e to the x squared plus 1, replace it by u. What's left? X dx is 1/2 du. Okay? Where do you put the 1/2? You can put it in front of the integral. Where do you put the du? At the end. Yes, everybody? And then we can integrate. What's the integral of e to the u? E to the u, right? Plus c. So what is u? Yes. Good. So this is the solution. Okay, everybody? So yes, practice more, think more. So the homework, you have a lot of exercise, and then today we will do a lot of examples. Okay, so the 4-step process. Okay. Yes. So think. Don't just look at the notes with answers. Think. I really hope that you fully understand. Okay, part D. Look at part D. What is the u? What is the inner function? X plus 1, right? You see the square root? Inside the square root, we have x plus 1. If we let u be x plus 1, what is du? 1 dx. Okay? The derivative of x is 1. The derivative of 1 is 0. And you need to multiply by dx. Okay, let's see. So we're gonna replace. Okay? We know the x plus 1 is u, so it's square root of u. And we know that dx is du. Do you see we still have an x left upstairs? So we don't want to put an x here because we don't drink mixture of orange juice and milk, right? We want to change everything in terms of u. So how can we express x in terms of u? Look at this relation. U minus 1, exactly. So this problem is a little bit harder because after we replacing the u and replacing the du, we get something else, right? We get the x. So you need to solve for x in terms of u. We get x is u minus 1. So x is u minus 1. Okay. The part D is a little bit harder than the previous examples. Because the previous examples, we just find the u and the du, we plug in, that's it. But this example, we have the x, right? So we have to do something else. Look at the relation between u and x. Solve for x in terms of u. Is everybody okay? Now, how do we integrate this? Do we have culture rule? No. If you see a quotient, what do? Simplify, split those two terms, right? Everybody, split them. We got u over square root of u minus 1 over square root of u du. What is u over square root of u? Do you remember that x to the a over x to the b is x to the a minus b? Yeah? So u to the upstairs is like u to the 1, right? How about downstairs? 1/2, exactly. And then the second term, u to the what? What power? Negative 1/2. Yes. What is 1 minus 1/2? 1/2. So u to the 1/2. Okay. Alright. So u to the 1/2 minus u to the negative 1/2 du. We need to integrate. Let's see. Blaine, what's the integral of u to the 1/2? Yes. You mean integral. U to the 1/2 plus 1, which is to the power 1? Okay. What is the formula? Integral of x to the p is x to the yes. In this case, our p is 1/2. So u to the 1/2 plus 1. What is that? 1/2 plus 1. Yeah, 3/2. Yes. So 3/2 over 3/2. Yes, everybody? Okay. And then minus the second term. Well, u to the yes. Good. Is everybody okay? We use the formula. X to the p integral is x to the p plus 1 over p plus 1. And when you divide it by a fraction, it's the same as multiply by its reciprocal. So 3/2 reciprocal is 2/3. Yeah, everybody? And u to the 3/2 minus over 1/2 is the same as multiply by 2. And what is u? What is u? X plus 1. Yes. To the 3/2 plus, minus 2 times x plus 1 to the 1/2 plus c. So this is the final answer. Is that okay, everybody? All right, so this problem is a little bit harder because after you plug the u and the dx, the du here, you have something else and change it in terms of u based on the u and x relation. Okay. All right, part E. If we get something like this, this is a quotient, right? Everybody, do we have quotient rule? Quotient rule for integral? No. So we gotta simplify it. Do you see the power of the numerator is bigger than the power of the denominator, right? In this case, we call this as an improper fraction. So, improper fraction. If the degree of numerator is greater or equal to the degree of the denominator, we call this as improper fraction. When you see an improper fraction, what do? You use long division or synthetic division, okay? But let's just use long division because long division always works. Synthetic division only works for x plus c or x minus c, okay? So let's use a method that always works in general. Okay, do you still remember long division? No? Okay. Let me remind you, like, how do you divide number? Like, if I give you 37 divided by 4, what do you do? Hey! Imagine you don't have your calculator with you and you don't have your phone with you. So you're thinking about what number? You multiply by 4, and you get the number is less than 37. What number do you multiply by 4 less than 37? 9. So we put the 9 here. 9 times 4 is 36. We use the first line, subtract the second line. What do we get? We get 1. So this is called the divisor. 9 is called the quotient. And 1 is called the remainder. Yeah? So 37 over 4 is the quotient plus the remainder over the divisor. This is how we divide numbers, right? So quotient plus remainder over divisor. Okay, now we're gonna divide polynomials. Do the same thing. 4x cubed plus x squared minus 3x plus 5 divided by 2x plus 3. Okay, so when you write down the expressions, make sure the order is from the biggest to the smallest. And then you look at the first term. Okay, look at the first term. So here you want to ask, what's multiplied by 2x? So what multiplied by 2x to get 4x cubed? 2x squared, exactly. You look at the coefficient and you look at the x power. Coefficient, what multiplied by 2 is 4? Yeah, 2. X power, what x power multiplied by x to get x cubed? X squared. Yes, everybody? So we put x squared here, and then we multiply the 2x squared with the divisor. So what's 2x squared times 2x? Yeah. What's 2x squared times 3? 2x squared times 3. 6x squared. Right. Now we use the first line. Subtract the second line. What happened? 4x cubed minus 4x cubed. Cancel. Yes? 4x cubed minus 4x cubed. Cancel. But x squared minus 6x squared is square. Yeah, minus 5x squared. And we have minus 3x minus 0 and a 5 minus 0. So they stay here. Right? Everybody? Okay. Now, continue. We look at the first term. What multiplied by 2x to get negative 5x squared? Look at the coefficient. Look at the number. What's multiplied by 2 to get negative 5?
-5 halves.
Yes, exactly. Right? You want to match the coefficients. You want to match the x power. So you're thinking about what multiplied by 2x to get negative 5x squared, which is negative 5 over 2x. Yes, everybody? Then, what do? Multiply. When we multiply by 2x, what do we get? Yeah. How about when we multiply by 3? Negative. Yes. Now use the first line. Subtract the second line. you see minus become plus, so that they cancel, right? Yeah, these two terms cancel. That's always the case. All right, the next term is negative 3x minus become plus 15 over 2x. What is that? What over 2? Yes, because this is negative 6 over 2. This is negative 6 plus 15 is 9. So 9 over 2x. We get 9 over 2x plus 5. And do you see this is degree 1? This is degree 1. They're the same. So we are able to keep going. So your remainder should be smaller than the divisor. Okay, so we keep going. Now what color that I haven't used? Blue. Okay, so what multiplied by 9 over 2x to get, sorry, I did the wrong thing. What multiplied by 2x to get 9 over 2x? Exactly. So we put 9 over 4 here. 9 over 4 times 2x is 9 over 2x. Sorry. Yeah. And then 9 over 4 times 3 is what? 27/4. Yes. And we use the first line, subtract the second line. Do you see the first term? Cancel. Right, everybody? The second term. What is 5 minus 27 over 4? Negative 7/4, right? Yeah, negative 7/4. Good. That's the remainder. And then whatever up there is our quotient. Oh, yes. So our integral, it becomes the quotient, which is 2x squared minus 5 over 2x plus 9 over 4, and then plus the remainder, which is negative 7 over 4, over the divisor, which is 2x plus 3 dx. Let's continue on Wednesday. Okay? So we can continue on Wednesday. This one is just polynomial. Can we integrate polynomial with our antiderivative formula? Yes, power rule. Right? You can integrate x squared, you can integrate x, you can integrate constant term. And this part we do use substitution. Okay. Have a nice day. Yeah, please do your homework, turn in the missing practice exam correction and wrapper as soon as possible, because if I see you miss something, I can let you know. And if you want the notes bonus, show me your notes. Okay, it just take me 5 minutes just to look through your notes. And make sure you don't miss some example, because if you miss one example, you will lose 0.1. So if you miss 10 examples, then you don't get any bonus. Okay, so my office from 1 to 1:50, and then 3:15 to 3:50, and then in Andover Common 244. Right, 242 from 4 to 5. Have a nice day. And please help me to fill the class evaluation. Thank you.